Here we are going to answer Computer Science Paper 2, Advanced Level 2021. And we're going to answer question number 4, sub 3. Now, jobs P1, P2, P3 need 6, 4, and 3 units of execution time respectively. They arrive at times 1, 4, and 6 respectively. Here we can see that processes we have P1, P2, P3, arrival time 1, 4, 6, burst time, or we call them jobs, 6, 4, and 3 respectively. It is being represented in a tabular form for better understanding. Now the question is, draw a Gantt chart for the jobs if each job is allocated a time quantum of 2 time unit at a time and the shortest job first scheduling policy is used. So the quantum time of 2 units and the shortest job first are condition for this Gantt chart to be drawn. So the Gantt chart actually is a CPU where the processes are going to be executed. So we have to come out with a ready queue where processes will be arriving and then they will be assigned to the CPU. So far P1 is the first process to arrive at the ready queue, and they arrive at 1, and the CPU is idle and is being assigned to the CPU at that 1, and at 2 it has executed 1 job. So it continues to 3 and execute 2 jobs. At this time the clock rings and we subtract 2 from 6, we have 4. Now when we look at the ready queue is empty, no process has arrived. However, we need to remove it and call it back to the CPU as the condition says. Now when we compare, there is no other job and it has to continue from 3 to 4. It has executed 3 jobs. Now at 4 a process P2 has arrived. However, we removed 1 from 4, we have 3 processes left for P1. But when we compare 3 and 4 burst time or jobs, it is discovered that 3 is the shortest and fulfill the condition, and so P1 is very happy to continue with the execution of the process. Therefore at 5 P1 continues and he has executed 4 jobs. Now the clock rings at 4 because this actually turns or go around for the quantum of 2, and when we subtract 1 from 3 we are left with 2. But when we look at 2 and 4, you discover that 2 is still the shortest, and so P1 is preempted and is brought back to continue with the process. At 6 it executes 5 jobs. Now at 7 it executes 6 jobs. When the clock rings, we removed the 2 from the 2 that is left there for P1. You discover that you are left with 0. Now at this point we need to compare which process need to come. When we look at P2, we discover that, but at 6 P3 has arrived. So we compare P2 and P3. You see that the burst time for P2 is 4 and the burst time for P3 is 3. 3 has the shortest job. 3 is the shortest job or burst time, and then 4 is not the shortest. So P3 is assigned the CPU. So as P3 goes, at 8 it executes 1 job. At 9 it executes 2nd job. The clock rings, we removed it from there and brought it back. And then at, I'm a little bit fast, I'm sorry for that, but at P3, at 9 or at 10 you have P3 continues with his job and is executed for 3 jobs already done, and we removed the remaining 1 that is left there. We're left with 0. So at this time P2 can come in and is the only process left, no competition anymore. At 11 it executes for 1. At 12 it executes for 2, and then the clock rings, removed it and bring it back, and so on and so forth. It executes for 3, execute for 4, and that is the end of the story. When we subtract the process from there, you see that no process is left again. This is the overall processes that we are talking about. So you see that the completion times are being given there, and P1 completes at 7, P2 completes at 14, and then P3 completes at 10. Now we are asked to calculate the average turnaround time for the processes. So to calculate the average turnaround time for the process, we must calculate the turnaround time for each process. So looking at it very carefully, we see that the turnaround time is equal to the completion time minus the arrival time. And having done the mathematics there, we come out with the averages, and the average turnaround time is 6.67 units. Now we have just profited to calculate the waiting time, though it was not asked, so it was just a plus in this exercise, and we're not going to talk about it again anymore. So I'm interested in calculating only this process, and I don't want the video to be too long. We are going to end it here. If you like to have more solutions to this, please subscribe, like, share, and comment, so that I should know what I'm doing is good or is bad. So thank you for your kind attention, and see you in the upcoming video.